Hello everyone, welcome back to my YouTube channel Physics Unification. In the previous videos, I have explained the first 5 chapters from the first PUC Science. Today we can discuss second PUC first chapter, that is electrical charges and fields. First of all, what do you mean by electric charge? Let us discuss. Electric charge, it is the physical property of matter that causes it to experience a force when placed in an electromagnetic field. ಆ ಮ್ಯಾಟರ್ ಏನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತದೆ, ಒಂದು ಫೋರ್ಸನ್ನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತದೆ ಯಾವಾಗ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಇಟ್ಟಿದಾಗ. ಆ ಅದನ್ನು ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಐದರ್ ಪಾಸಿಟಿವ್ ಆರ್ ನೆಗೆಟಿವ್. ಲೈಕ್ ಚಾರ್ಜಸ್ ರಿಪಲ್ ಈಚ್ ಅದರ್ ಆ್ಯಂಡ್ ಅನ್ಲೈಕ್ ಚಾರ್ಜಸ್ ಅಟ್ರಾಕ್ಟ್ ಈಚ್ ಅದರ್. ಅಂದ್ರೇನು, ಪಾಸಿಟಿವ್ ಇದ್ದರೆ ರಿಪಲ್ ಆಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಇದ್ದರೆ ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. An object with no net charge is referred to as electrical neutral. SI unit of electric charge is Coulomb and dimensional formula, that one is AT. Next, we can discuss the concept of conductors and insulator. Conductors means the substance which allow ಮಾಡ್ತದೆ passage of electricity are called conductors. Example, metals, human beings, animal bodies and earth surface. The substance which do not allow the passage of electricity are called insulators. Example, non-metals like glass, plastic, wood, etc. Next one, it is basic properties of electrical charges, and this one is important for 2 marks. There are 3 properties are there. One, it is additive property, another one it is conservation of charges property, another one it is quantization of charge property. Additivity of charges means total charge is equals to the sum of individual charges, and conservation of charges means total charge of an isolated system remains unchanged. Total charge ಏನಾಗಿರುತ್ತೆ, unchanged ಇರುತ್ತೆ with time. ಯಾವ ಸಿಸ್ಟಮ್ ಒಳಗೆ? Isolated system. Third one, it is quantization of charge. Here, charge can be written as it is the integral multiple of the basic unit of charge. That one is Q is total charge, he is the basic unit of charge. These are the some main charges we can refer in the day-to-day life. Milli Coulomb means 10 to the power of minus 3 Coulomb. Micro Coulomb means 10 to the power of minus 6 Coulomb. Nano Coulomb is 10 to the power of minus 9 Coulomb. And the value of charge E is equals to 1.60219 into 10 to the power of minus 19 Coulomb. That is approximately 1.6 into 10 to the power of minus 19 Coulomb. Approximately there are 6.25 into 10 to the power of 18 electrons are present in the charge of 1 Coulomb. 1 Coulomb ಒಳಗೆ ಇಷ್ಟು ಚಾರ್ಜ್ ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತೆ. ದಟ್ ಒನ್ ಇಸ್ 6.25 into 10 to the power of 18 electrons. Next one, it is Coulomb's law, and this one is very important for 3 marks. Means whatever we should write, statement and then equation we should write in the examination. Statement: the electrostatic force between 2 point charges, 2 point charges ತಗೋತೀವಿ, one it is q1 and another one it is q2, is directly proportional to the product of the magnitude of the 2 charges. ಈ 2 ಚಾರ್ಜಸ್ ಇಂದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ತಗೊಂಡಾಗ ಹಾಗೆ ಪ್ರಾಡಕ್ಟ್ ತಗೊಂಡಾಗ ಏನು ಬರುತ್ತಲ್ವಾ, ಅದಕ್ಕೆ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರುತ್ತೆ and inversely proportional to the square of the distance between charges. Here F can be written as K into magnitude of Q1 Q2 divided by R square. That is F is equals to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. Here value of K is constant of proportionality. K is equals to 1 by 4 pi epsilon naught, and the value of K can be written as 9 into 10 to the power of 9. And here epsilon naught is permittivity of free space, and the value of that permittivity of free space is 8.854 into 10 to the power of minus 12 Coulomb square per Newton per meter square. Next one concept, it is Coulomb's law in vector notation. Coulomb's law na vector notation alli denote ಮಾಡೋದು. This one is the diagram for that Coulomb's law in vector notation. Let us consider two charges Q1, Q2 having position vectors R1, R2. Force on Q1 due to Q2 can be written as F12. Then by Coulomb's law in vector notation, how we have to write? F21 bar is equals to 1 by 4 by epsilon naught Q1 Q2 divided by R21. ಅಂದರೆ ಸೆಕೆಂಡ್ ಚಾರ್ಜ್ ಇಂದ ಫಸ್ಟ್ ಚಾರ್ಜ್ ಮೇಲೆ ಕೂಲಮ್ಸ್ ಲಾ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ಈ ತರ ಬರಿತೀವಿ. ಇಂಟು R21 ಕ್ಯಾಪ್. ವೆಕ್ಟರ್ ನೋಟೇಷನ್ ಅಲ್ಲಿ ನಾವು ಕೂಲಮ್ಸ್ ಲಾನ ಹೇಗೆ ಬರಿತೀವಿ? F is equals to 1 by 4 by epsilon naught Q1 Q2 divided by R square into R cap. ಅದನ್ನೇ ನಾವು ಟು ವೆಕ್ಟರ್ಸ್ ಅನ್ನ ಹಾಕಿ ಬರೆದಿದ್ವಿ. 2 ಚಾರ್ಜಸ್ 2 ಮತ್ತೆ 1 ಚಾರ್ಜಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿ ಕೂಲಮ್ಸ್ ಲಾ ಬರೆದಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ದ ಫೋರ್ಸ್ F12 ಆನ್ ಚಾರ್ಜ್ Q1 ಡ್ಯೂ ಟು ಚಾರ್ಜ್ Q2 is obtained from equation 1. ಈ ಇಕ್ವೇಷನ್ ಇಂದನೇ ನಾವು ಇಂಟರ್ಚೇಂಜ್ ಮಾಡಿ ಮತ್ತೊಂದು ಇಕ್ವೇಷನ್ ನ ಬರಿತೀವಿ. ದಟ್ ಒನ್ ಇಸ್ F12 ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ 1 by 4 by epsilon naught Q1 Q2 divided by R12. 1 ಇಂದ 2ಗೆ ಚಾರ್ಜ್ ಆಗ್ತಿದೆ. Square into R12 cap, and that one is equals to negative of F21, means reverse of F21. ಇದು ಜಸ್ಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ ನಮಗೆ ಇದರದ್ದು ರಿವರ್ಸ್ ಇದೆ ಇದು. Therefore R12 vector can be written as minus of R21 vector. That is, two charges exert equal and opposite forces on each other. ಒಂದಕ್ಕೆ ಮತ್ತೊಂದು ಚಾರ್ಜ್ ಈಕ್ವಲ್ ಮತ್ತು ಅಪೋಸಿಟ್ ಫೋರ್ಸಸ್ ಅನ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತದೆ ಅಂತ ಅರ್ಥ. ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ಟೂ ಲೈಕ್ ಚಾರ್ಜಸ್ ಇಸ್ ರಿಪಲ್ಸಿವ್. ಎರಡು ಲೈಕ್ ಚಾರ್ಜಸ್ ತೊಗೊಂಡ್ರೆ ಐದರ್ ಇಟ್ ಮೇ ಬಿ ಪಾಸಿಟಿವ್ ಪಾಸಿಟಿವ್ ಆರ್ ನೆಗೆಟಿವ್ ನೆಗೆಟಿವ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ದಟ್ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ಟೂ ಲೈಕ್ ಚಾರ್ಜಸ್ ಇಸ್ ರಿಪಲ್ಸಿವ್. ದಟ್ ಒನ್ ಇಸ್ Q1 Q2 ಇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0. ಆ ಕೇಸಲ್ಲಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0 ಇರುತ್ತೆ. ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ಟು ಅನ್ಲೈಕ್ ಚಾರ್ಜಸ್ ಇಸ್ ಅಟ್ರಾಕ್ಟಿವ್. ಅನ್ಲೈಕ್ ಚಾರ್ಜಸ್ ಮೀನ್ಸ್ ಐದರ್ ಪಾಸಿಟಿವ್ ನೆಗೆಟಿವ್ ಅಥವಾ ನೆಗೆಟಿವ್ ಪಾಸಿಟಿವ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ Q1 Q2 ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ 0 ಆಗಿರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಡೆಫಿನೇಷನ್ ಆಫ್ SI ಯೂನಿಟ್ ಆಫ್ ಚಾರ್ಜ್. ದಟ್ ಒನ್ ಇಸ್ ಕೂಲಮ್. ದಿಸ್ ಒನ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ 1 marks. 1 Coulomb is the charge which when placed at a distance, ಒಂದು ಸರ್ಟೆನ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ನಾವು ಪ್ಲೇಸ್ ಮಾಡಿದಾಗ ಆ ಕೂಲಮ್ ಅನ್ನು ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? ಆಫ್ 1 meter ಫ್ರಾಮ್ ಅನದರ್ ಚಾರ್ಜ್ ಆಫ್ ದಿ ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್. ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ನ ಮತ್ತೊಂದು ಚಾರ್ಜನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಇನ್ ವ್ಯಾಕ್ಯೂಮ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ of magnitude 9 into 10 to the power of 9 Newton. Next concept, it is forces between multiple charges, and this one is important for 3 marks, and so this one is also called as superposition of multiple charges. Statement: force on any charge means Q1 due to a number of other charges means Q2 Q3 so on up to Qn is the vector sum of all the forces on that charge. Q1 ಮೇಲೆ ಆಕ್ಟ್ ಆಗಿರೋ ಫೋರ್ಸಿಗೆ ಈಕ್ವಲ್ ಇರ್ತದೆ ಡ್ಯೂ ಟು ದಿ ಅದರ್ ಚಾರ್ಜಸ್ Q2 Q3 Q4 so on up to Qn taken one at a time. ಮತ್ತೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಓದ್ತೀನಿ. ಫೋರ್ಸ್ ಆನ್ ಎನಿ ಚಾರ್ಜ್ ಡ್ಯೂ ಟು ಅ ನಂಬರ್ ಆಫ್ ಅದರ್ ಚಾರ್ಜಸ್ ಈಸ್ ದಿ ವೆಕ್ಟರ್ ಸಮ್ ಆಫ್ ಆಲ್ ದಿ ಫೋರ್ಸಸ್ ಆನ್ that charge due to the other charges taken one at a time. Let us consider with the diagrams. Consider end point charges Q1, Q2, Q3 so on up to Qn placed in vacuum at point whose position vectors are R1, R2, R3 and so on up to Rn. According to principle of superposition theorem, force on Q1 is equal to the F12 plus F2 F13 plus F14 plus so on up to F1n. From Coulomb's law, force exerted on Q1 by Q2 can be written as F12 vector is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R12 square R12 cap. Similarly, F13, that is force exerted on Q1 by Q3, can be written as 1 by 4 pi epsilon naught Q1 Q3 divided by R13 square R13 cap, and so on. Therefore, net force can be written as F1. Here, F1 is equals to F12. F12 is 1 by 4 pi epsilon naught Q1 Q2 divided by R12 square R12 cap, plus F13 is 1 by 4 pi epsilon naught Q1 Q3 divided by R13 square R13 cap. So on up to 1 by 4 pi epsilon naught Q1 Qn divided by R1n square R1n cap. That is F1 is equals to Q1 divided by 4 pi epsilon naught, because here Q1 is common in all the terms. Just take outside, and 4 pi epsilon naught is also common. F1 is equals to Q1 divided by 4 pi epsilon naught summation of I is equals to 2 to n. ಅಂದರೆ 2 ಇಂದ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ಸ್ ಚೇಂಜ್ ಆಗಿದೆ, ಅದನ್ನು ನಾವು I ಇಂದ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. I is equals to 2 to n Qi divided by R1I square R1I cap. This one is the forces between multiple charges. Next one concept, it is electric field. Electric field due to a charge Q at a point in space is defined as the force that a unit positive charge would experience if placed at that point. ಆ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಯಾವ ಫೋರ್ಸನ್ನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತದಲ್ವ, ನಾವು ಅದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದ ಫೋರ್ಸ್ F exerted by a charge Q on a charge small q is F is equals to 1 by 4 pi epsilon naught capital Q small q divided by R square into R cap. ಇದು ಹೇಗೆ ತಗೊಂಡ್ವಿ ನಾವು? ಸೇಮ್ Q1 Q2 ಇರೋ ಜಾಗದಲ್ಲಿ ಕುಲಮ್ಸ್ ಲಾದಲ್ಲಿ Q1 Q2 ಇರೋ ಜಾಗದಲ್ಲಿ ಕ್ಯಾಪಿಟಲ್ Q ಮತ್ತು ಸ್ಮಾಲ್ q ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ. Next one, it is expression for electric field due to a point charge Q at a point R can be written as E of R is equals to 1 by 4 pi epsilon naught. Only point charge ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ Q, ಆವಾಗ E of R is equals to 1 by 4 pi epsilon naught Q divided by R square ಅಂತ ಬರಿತೀವಿ into R cap. The magnitude of electric field due to a point charge Q at a distance R from Q can be written as in magnitude E is equals to 1 by 4 pi epsilon naught magnitude of Q divided by R square. That is, the electric field is radially outward. Electric field ಏನಾಗಿರ್ತದೆ, ಔಟ್ವರ್ಡ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಮೂಮೆಂಟ್ ಆಗ್ತಿರ್ತದೆ ಫ್ರಾಮ್ Q. ಇಫ್ Q is ಪಾಸಿಟಿವ್ ಇದ್ದರೆ ಔಟ್ವರ್ಡ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಮೂಮೆಂಟ್ ಆಗ್ತದೆ, and radially inwards if Q is negative. SI unit of electric field is Newton per Coulomb or volt per meter. Dimensional formula can be written as ml t minus 3 a minus 1. Okay. Next one, it is expression for electric field due to a system of charges, means more than one charges. If you consider there is number of charges Q1, Q2, Q3 so on up to Qn, and which is at a distance of R1p, R2p and R so on up to Rmnp. This one is a diagram for electric field due to a system of charges. Let us consider, see here it is E1, E2, E3, E4, means there are more than one charges is there. For that one, what we can consider, these are charges Q1, Q2, Q3, Q4. For those charges, we can consider electric field as E1, E2, E3 and E4. R1p, R2p, R3p and R4p are the distances. Let us consider what we have to check. Electric field produced by Q1. Q1 means this charge at P. At P means one particular point P. Can be written as 1 by 4 pi epsilon naught Q1 means charge, point charge it is, therefore Q1 divided by R1P whole square, because the distance between Q1 and point P is R1P into R1P cap, by Q2 can be written as E2 is equals to 1 by 4 pi epsilon naught Q2 by R2P whole square R2P cap. According to principle of superposition of electric fields, what we can write, E can be written as E1 plus E2 plus so on up to En. Here, in all the expression for electric field, 1 by 4 pi epsilon naught is common. So what we can take, 1 by 4 pi epsilon naught, just take outside, and inside the bracket what we can write, E1 means Q1 by R1P square R1P cap, that one we have to write here, plus E2 means Q2 divided by R2P whole square R2P cap, plus so on up to Q1 divided by RNP whole square RNP cap. And finally, what we can write, expression for electric field due to system of charges can be written as E is equals to 1 by 4 pi epsilon naught summation of I, which changes from 1 to n, Qi. Qi means here value of I which is changes from 1 to n, 1 to up to n. So I is equals to 1 to up to n, Qi divided by RIP whole square into RIP cap, and this one is the expression for electric field. Next concept, it is electric field lines. It can be defined as, it is the way of pictorially mapping the electric field around a configuration of charges. Electric field lines is a curve drawn in such a way that the tangent to it at each point is in the direction of the net field at that point. Electric field usually ಏನನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತದೆ, ಅದು ಟ್ಯಾಂಜೆಂಟ್ ಅನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತದೆ, ಮೀನ್ಸ್ ಅದನ್ನು ಡಿನೋಟ್ ಮಾಡ್ತದೆ at each point in the direction of the net electric field. Electric field lines are curved near the strong electric field and which is weak when it is far apart from the region. In the region of constant electric field, what we can write, electric field lines are uniformly spaced parallel to that straight line. Okay, next one, it is electric field lines from a positive charge. For positive charge, that electric field lines are moves radially outwards. Just see here, this one is the point charge Q and all the electric fields which are moving outwards. In case of negative electric field, in case of negative charges, electric field lines are moves radially inwards. Let us consider that one is the point charge Q and all the electric fields are moving inwards, and this one is the diagram for electric field lines between unlike charges. Unlike charges means one it is positive charge, another one it is negative charge. When unlike charges is there, which creates a dipole, and which electric fields are moved from positive to negative, negative to positive. And when it is repulsive, repulsive means same positive charge, either it may be negative charge. Then what happens, electric field lines are repel each other, they will not meet at any point. And these four diagrams are important for 2 marks. Next one concept, it is properties of electric field lines. First one, it is electric field lines. We know that when it starts from positive charge and end up with negative charge. In a charge free region, electric field lines can be taken to be continuous without any breaks. Two field lines can never cross each other. ಎರಡು electric field lines cross ಆಗ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. Electrostatic field lines do not form any closed loop. Closed loop ಅನ್ನು electric field lines create ಮಾಡೋದಿಲ್ಲ. These are some properties of electric field lines. Next one concept, it is electric flux. Electric flux, delta phi through an area element delta S can be written as E into delta S. E into, just by removing that vector sign, what we will get? E into delta S into cos theta. And here phi is nearly equal to summation of E into delta S. SI unit of flux can be written as Newton per Coulomb meter square or Coulomb per meter. Dimensional formula for electric flux can be written as ml cube T minus 3 A minus 1. Here what we can write, electric flux, that one can be taken as maximum when theta is equals to 0. Means angle between E and delta S is equals to 0. Then E is parallel to delta S. Electric flux is minimum. Minimum yavagagutte? When angle between E and delta S is 90 degree. Here E is perpendicular to delta S. Which completes the first part of this chapter, electric charges and fields. Stay tuned, like, share and subscribe my YouTube channel Physics Unification. Thank you.